All right, we're going to be starting chapter 20. And so we just finished confidence intervals, and that tells us a little bit about a sample and trying to track that true proportion, P. But this chapter is all about testing hypotheses. So what if we knew some sort of P and we did a sample? How do we know if that sample is even relevant? Right? So we're going to be talking about hypothesis testing. And we're only going to get started a little bit today because of time. But we're going to first start with an example from our book and then work through the first two steps of the hypothesis. There's really 4 steps to a hypothesis test. And we're going to get to the very first 2 this morning because I don't think that they're that difficult. All right, so here's the example from the book. And they're talking about these things called ingots, all right? And all they are these huge metal pieces like you would use on an airplane, like they melt down on the metal and form it all. And if you're going to use them on big machines like an airplane, then you obviously can't have any cracking, all right? So they're trying to change their process for melting these down and shaping them so that they reduce the cracking rate. So we have 400 of these things, and it's a random sample. And we know that each random sample will have a somewhat different proportion of cracked ingots, which is true. Every sample is a little bit different. But they observed 17%, all right? And we want to know whether that 17% that we observed is a result of natural sampling variability or sampling error, or is this lower cracking rate strong enough evidence to assure management that the true cracking rate now is below 20%. You have 2 different numbers. You have 17%, which is a p hat, that's your sample, and you have a p, you have 20%, which is what the management thinks that the proportion of cracking is. We want to know if the 17% in the sample is evidence enough that we have changed that process and it is actually a lower cracking rate now. People want answers to questions like these all the time. Has the president's approval rating changed since last month? Has teenage smoking decreased in the past 5 years? Is the global temperature increasing? Did the Super Bowl ad we bought actually increase sales? And so if we have some baseline P and we have a sample P hat, then we can test hypotheses about some models to decide, oh, yeah, this is relevant or no, it's not, or this is significant or no, it's not. Okay? So to do our hypothesis test, again, 4 steps, right? There is a carefully structured path. We're going to do several hypothesis tests. We're doing one about proportions right now. In a few chapters, we'll do one about 2 proportions, about means and 2 means, all sorts of things. But the same 4 steps generally apply, all right? That's why we have 4 sections. The first section is the hypotheses. I know that's shocking, all right? Now, there's 2 different hypotheses, all right? So first we have the null hypothesis. That's a claim that nothing is different, okay? The null hypothesis is always no change. And then we have a second hypothesis, the alternative hypothesis, that we think things are changing, okay? So, shorthand, H naught, H sub 0, that's the null hypothesis, and we have H sub A as our alternative, okay? Now, since we're talking about proportions in this chapter, our parameter is going to be P. All right, that's our true proportion that's given to us. Okay? Our alternative is also going to be about P. All right, it's always going to be about P. We're basing things on what we think the true proportion is. We're trying to do the test to see if it has changed. So we always base everything on P. Now there's 2 types of alternative hypotheses. All right, your null hypothesis is always going to be P equals some number. But your alternative can be 3 different things. It is also going to be about P, but there's a 2-sided alternative. And that means we just want to see if it's changed at all. All right, we're going to base this on a normal model. Shocking, we'll talk about that later. But if we're talking about no change, then we're going to talk about probabilities that this occurs or probability this occurs. We'll get into all that. And so we would have P is not equal to whatever that number was in our null hypothesis. Often, though, we have one-sided alternatives. We want to know something's increasing or something's decreasing. And so we have P is greater than or P is less than, all right? So those are your only three options for your alternative, not equal to, greater than, or less than. If you're trying to compare that to the null hypothesis, again, no change, that P is equal to something. So using that ingots example, the metal pieces, all right, how can we test a hypothesis about ingot cracking? All right, so the null hypothesis is that there is no change. So we have the null hypothesis, P equals, and we use whatever management told us. We are going to write a null hypothesis that there has been no change, and then if our test shows that we have a super low probability of our sample happening, then we will make some conclusions based off of that. But we're going to start off with there's no change. Now we think that the ingot cracking is being reduced. We have our alternative hypothesis that P is less than 0.2, right? So notice, again, we're using P, not P hat, and we're using whatever we think P is in both of our hypotheses. Something is equal to, and then because we think there's no change, and then for the alternative, something's changed. So let's see if we can practice that concept. So here is a quick example. Write the null and alternative hypotheses you would use to test each of the following situations. So in part A governor is concerned about his negatives, the percentage of state residents who express disapproval of his job performance. His political committee pays for a series of TV ads, hoping that they can keep the negatives below 30%. They will use follow-up polling to assess the ad's effectiveness. So our null hypothesis is that P is equal to 0.3. There's no change. But we're hoping that they can keep the negatives below 30%. So our alternative is P is less than 0.3. Right? Again, this is a very important step. Before you do anything else and before we go into any of the other details of our test, we have to have hypotheses. On part B, is a coin fair? Well, if we think a coin is fair, then we're going to say that P is equal to 0.5. Right? 50%, heads, tails. Now it just says, is it fair? It doesn't say if it's going to have more heads or more tails. It doesn't specify any of that. So they just want to know if there's going to be any change at all. So if there's going to be any change at all, we have P is not equal to 0.5. And then the last one on C, only about 20% of people who try to quit smoking succeed. Sellers of a motivational tape claim that listening to the recorded messages can help people quit. So again, we have a null hypothesis. We say no change, so P equals 0.2. But the sellers of this tape claim that listening to the recorded messages can help people quit. So we think that P is going to be greater than 0.2. People who try to quit smoking and succeed. They listen to these tapes. We're going to see if it's greater than 0.2. So these tapes really help. Okay? That's all there is to the hypotheses. The only other thing you could do is write it all out into words, and that's fine. And we might do that in other chapters, but not necessarily in this one. So we have a null hypothesis, null meaning nothing, meaning no change, and an alternative showing there's some sort of change in that P value, that P proportion. Okay? So, after the hypotheses, we have to talk about our model. All right, so to specify the model you will use to test the null hypothesis and the parameter of interest. All right, and then look what it says. This should not be surprising to anybody. Of course, all models require assumptions. You'll need to state them and check any corresponding conditions. Huh, hilarious. So we're talking about proportions. And so if we're talking about proportions, just like we did in chapter 19, then our model is going to be a normal model, the sampling distribution model we talked about in chapter 18, all right? So the conditions are the exact same. There are no new conditions. We're talking about proportions. So we have the independence assumption. We talk about if it's a random sample or not. if the sample is less than 10% of the population. And for the sample size assumption, we talk about MP and NQ being greater than or equal to 10, success failure condition. You're still checking all of those. Just like I took off points in chapter 19 when you didn't check the conditions, I will keep doing it. And I'm sorry to tell you, there are going to be conditions for every single chapter for the rest of the year. You have to check the condition. Now, so you're going to have two hypotheses. You're going to check your conditions. And after you check your conditions, you're going to make a statement. Okay? And your statement is going to be something like this. Because the conditions are satisfied or are met, or whatever you want to say, I can model the sampling distribution of the proportion with a normal model. You need to tell them what model you're going to be using. We're going to be finding probabilities with a normal model, so like with normal CDF in your calculator. So if you don't tell them what model you're using, and you write down stuff from your calculator, which they're not going to look at, an AP grader is not going to be very happy. So you specify the model, okay, so that they know what you're using later. Now, it also says, down here I start it, let's say the conditions aren't met. Well, then you can't do anything. So because the conditions are not met, I can't proceed with the test. You're allowed to say that too. But you should check your conditions and then make a statement. Now, I would like to see one more piece to this statement. All right, I know I haven't done anything, but the test about proportions is called a one proportion z-test. I know we're very creative here in statistics. In chapter 19, we had a one proportion z-interval. Okay, so these are not hard names to remember. Once you specify the model, though, you need to add in the sentence, I can perform a one proportion z-test. You're going to name the model, and then you're going to name the test you're using. Again, we're going to be doing multiple hypothesis tests, so the sentence won't always be exactly the same, but it'll include the same information. Check the conditions so they're met. I'm using this model, and I'm using this test. Okay? So that's where we're going to stop today. I haven't done anything, so you don't really know what the test is all about or anything. But you should be able to write hypotheses if I give you a scenario, and you should be able to check the conditions about those hypotheses. Right? Again, the conditions are the exact same they've been. Right? Tomorrow, we're going to go through all four of the steps in the process, and we're going to go through and do an example from start to finish. They're going to seem a little bit long, but all of those pieces that I'm doing are all important. And you'll be graded on all those key pieces in every single free response, every single quiz, every single test. So you need to make sure you know these pieces. So the first two steps are hypotheses, then naming the model and the test.